Hi there once again and welcome to another Expresso Mechanic tutorial. And this is going to be another Python effector that we're going to be building today. As you can see on the screen, we've got it here. And I'm calling this one a Multi Effector because it has 5 separate functions. That's what we're about in this tutorial. So without further ado, let's see if we can make this happen. Those of you that have seen my Python Bytes tutorial on lists and how they're your best friend will know that I created this setup in there. For those of you that haven't seen that tutorial, I'll put a card on the screen should you wish to do so. But if you don't want to, just as a quick recap, all we did was define some global variables here. We also added up here the MoData color. We put that in as the color array. And down here at frame 0, we defined the lists. So all we did was put the index values of the necessary clones, and if we just go into our cloner here, we can switch on the index values. Just switch to the top view so that we can look at this. So in the red you've got 19, 20, 25 and 26, and you can see that they correspond here. And similarly with the green, the blue, the yellow, and also the surround, the orange ones around the edge. That's all we did. We put the necessary index values into those lists. And then defined a setup function here with a for loop which counts through, well, in fact sequences through, I suppose I should say, from 0 to 35. So all of the clones are sequenced. And then we checked to see which of the lists they actually fell into. And if they were in the red ones, we made them red, green, etc. And that's how we set them up with the colours. And that's all we did in that tutorial. That's how we left it. And of course, we did that at frame 0, but we called the setup function at all times. So it doesn't matter whether it's at 0 or any other time, it just gets called. And finally, we just updated the MoData for the color array as a last step, just to finish it off that far. That's as much as we did. So in this tutorial, we're going to turn this into an all singing, all dancing effector. I'm just going to select my 3D view again, and we'll turn off the index values there so that we can see everything properly. Okay, so let's continue with this and get things underway. As the yellow squares are going to flash on and off, the first thing we need to do is define a flag array. So we'll say far and then copy this, paste it in here, and this will be MoData underscore flags. We can also come down to the bottom here, copy this, paste it in there, and MoData flags far. And that sets the MoData flags up for us, and it will refresh at the bottom, so we don't have to worry about that anymore. Moving on from here, we can define some more global variables. So the first thing we can say is global start time R for red. And then we can copy this, paste it in, replace the R with a G, paste it in again, replace the R with a B, do the same again, and replace the R with an S for surround. So that sets up our global variables so far. We can then say global flip underscore flop and global counter, because we need one of those too. And that really does complete all of our global variables. So that's the initial definition of those done. Moving on from here, we can come into our frame 0 if statement here and add some more initializations. So we can say start time underscore R is equal to an empty list. Copy this, drop it in here, replace the R with a G. Same again, replace the R with a B. And finally, replace the R with an S. And that sets all of those up for us. We can then say flip-flop is equal to, and I'm going to put a 0 between the brackets initially, and then finally counter is equal to, and I'm going to put -1 between the brackets. And that's the setup done. So we've got all of our variables are defined and they're all initialized as need be. So that's great. We can move on from here. Before we think about defining our main function, we just need to add some user data. So I'll make a bit of space here and then we can think about sorting that out. So with our Python effector selected, we can simply say add user data. And then with this data here, I'm just going to call it red. And this will be a spline. And I'm also now going to command drag to copy it, call it green, and do the same again and call this one blue. That's great, and we can just hit OK, and we've got our splines ready to go. So the next thing we need to do is set these curves up in here. So in the first one, we can just command click 4 times to give us 4 points. It's already twirled open and we can see where the points have got to go. The first one we can drag down to 0 on the X and 0 on the Y. And the final one, in fact, what I need to do, thinking about that, it's not 0 on the X and 0 on the Y, it's 0.5 on the Y. That's fine. And then the same with this one. We need 0.5 on the Y and we want 1 on the X. And then these two we can work out from here. So this needs to be 1 on the Y and 0.25 on the X. And this needs to be 0.75 on the X and 0 on the Y. And that's given us our basic shape, but we need to work with the tangents. This first tangent here should be 0.05. Oops, I've done that wrong. Didn't get the tangent. 0.05. That's where that should be. The same with this tangent here, minus 0.05. And then these two should be minus 125 and 20 and 125, and the same here, so minus 0.125. And that's fine. That's given us our first spline curve. So that's red set up. Green, we need to set this up as a bell curve. So in here, again, command click, and we'll do it 3 times to create 3 points. Our first point can be at 0 on the X and 0 on the Y. And our final point, 1 on the X and 0 on the Y. And then the middle point here, we can make it 0.5 on the X and 1 on the Y. And then we need to work again with the tangents, and these need to be 0.25, which is correct there. 0.25 here, or minus 0.25. And then finally 0.25 here, or rather minus actually. And that will sort itself out. And that's great. That's given us the bell curve that we need for the greens. And then finally the blues. This is a really easy one. It's just 2 points. So we can click here, drag this one up to 1 and 1 on both axes, and the initial point 0 and 0 on both axes. And the tangents, again, the right hand tangent here needs to be 0.25, which it is, and this tangent here needs to be minus 0.25. That's set up as we need everything to be. So all our user data now, our splines for our user data, all correct and ready to go. So the next thing to do then is to drag them into the expression editor here and remove the word Python. And we can simply say r_spline is equal to op. And that gets our first spline variable set up. Drag the green in and do the same thing again. Say r_spline, or rather g_spline, not r. Just done that one, and that will be is equal to op. And then finally the blue. Drag this in. Let's just make sure we do this in the correct place. Oops, that's no good. Let's go down and click on that again. Drag that one in. B_spline is equal to op. And that's our user data dragged in and ready to go. Before we move on though, I've just got a bit of an error here. Need to sort that out. Just take away that from in there because that will cause us a problem if we don't. Okay, that's great. We're ready to go. So the next step then is to define another function. And this is going to be the main function that drives everything. So we can say def animate, and then we're ready to put some code in here. The first thing I'm going to say is if frame is greater than 0 and frame, and it will be percent for modulo 30 is equal to 0. Moving on from here, I'm going to say if flip flop brackets 0 is equal to 0, flip flop dot clear, and then flip flop dot append brackets 1. I can then say else flip flop dot clear, flip flop dot append brackets 0. So if our frame or if our timeline has been started and is greater than 0 and it's also hit 30 or any multiple of 30, then what we want to do is check the status of our flip-flop. And if it contains a 0, because remember the flip-flop is also a list, it's a list and it only contains one element. So if the flip-flop contains a 0, we want to clear it out and then append it with a 1. Alternatively, if the flip-flop contains a 1, we want to clear it out and then swap the 1 for a 0, so that it alternates. And it's going to do this every 30 frames. So that's what we're doing in here. I can then say if frame, and this time it will be modulo 3, is equal to 0, if counter brackets 0 is equal to 19, counter dot clear, counter dot append brackets 0, and then again else counter brackets 0 plus equals 1. So here we're saying that for every third frame we're going to basically check the status of our counter, and if the counter or the number within the counter is 19, it needs to be cleared and then set back to 0. Otherwise it just needs to be, well, incremented by 1. That's what we need to do. We need to add 1 to the value every 3 frames until we reach 19, and then we can reset the counter. That's what we're doing with this little piece of code. Okay, that's great. So that's our first 2 little pieces of code set up within our animate function. And now we can move on to the main loop. Actually, before we go any further, I've just seen a spelling mistake here. Just take that away. That's better. That's much better. Fine. Okay, then great. So what we can do now is start dealing with our red squares. We'll deal with those first. So we can say for I in range len red, and then we'll start coding what we need to do here. So we can say then if len start time underscore r is less than 1, start time underscore r dot append frame. And you've seen me do this before, but normally, of course, there would be a trigger variable set up as well. We don't actually need one on this occasion because we're going to be using these monoflops that we're defining here, the monoflop and range mappers. We're going to be using those constantly, so we don't need any kind of trigger on this occasion. So we can move on from here and say duration is equal to frame minus start time r brackets 0. And as per usual, that gives us a 0 starting point because we're technically subtracting frame from itself to give us 0. Moving on from here, we can say if duration is less than 30, and in here range mapper is equal to, and it will be c4d.utils.range map brackets, and at first duration, and then our input range, which will be 0, 30, and then our output range, which will be 20, minus 20, because we want these to move up and down. So from a 0 starting point, we want them to move up 20, then come back down, and then back down 20, and then back to 0. And if we check out our user data in the spline here, we can see this will be the 0 point, this will be 20, down here will be minus 20, and this will be back to 0. That's how this is going to work. So we can say comma false, and we must do that because we're using negative values as well as positive values, and then r underscore spline, so that we use our spline data that we've defined here. And that sets up our first range mapper. We can then say x is equal to, and it can be mar brackets red open bracket again, I double close dot off dot x, and then y will equal range mapper because we're moving them up and down along their y-axes. And then finally z will be the same as we've got here, so we'll copy that, paste it in there, and just put a z on the end. Okay, so that's fine. So we'll keep them in their current positions in the x and z, but we'll move them up and down in the y. That's what we're doing here. And then to finish this piece off, we can simply say mar brackets red brackets I double close dot off is equal to c4d dot vector brackets x comma y comma z, and that will move our cubes up and down. Finally, to finish off this little piece of our code, we can say else start time underscore r dot clear, and that will set things up ready for the next cycle. So that's our red squares here taken care of, our red clones taken care of. Moving on from here, we can say if len, and it will be start time underscore g this time is less than 1. And again, it will be the same code as we've got up there, so we can copy some of this code and make amendments as we need to. So we'll copy these 3 lines and paste them in here, and that's fine because we know that we need to append start time g. We just need to update that, so that's fine. And down here we need to say start time g as well, but everything else can stay exactly the same because it's identical to what we've previously done. We can now define our second range mapper, so we'll copy this and just change the values as need be. Drop that into there. So we can say here it is going to be 0,30 for the input range, but we're going to use 1 and 0.1 as the output range. We'll say false in there still, and we'll change this to G_spline because of course we're going to be using this spline. And for the greens we're going to be scaling these. That's what we're going to be doing here. So we've got all of that set up as need be. And now we can say mar square brackets green square brackets I double close dot scale, and we can simply say range mapper, and that will uniformly scale our green clones. To finish off again, we simply need to say, in fact I'll copy it from here, and it's else start time G dot clear, and that completes the code for the green clones. Moving on from here, we can work with our blue clones. So again, we can simply say if len start time underscore b is less than 1, start time b dot append frame. Actually, I haven't done that correctly, have I? B dot append frame. And what I'll do, in fact, is copy the rest of this code from up here. Drop that in there. Okay, great. So we can just check this. Start time B just needs to be placed in there. And again, the duration is less than 30. That's fine. So that line doesn't need to be altered. But again, we've got to do some alterations within the range mapper here. So we're going to start from 0 and we're going to say 360 in here. We'll leave false in there and we'll say B-spline in there. Because of course the blues are actually going to rotate. They're going to rotate around their axes in this direction. They're going to be rotating towards us basically. So let's see where we go from here. We can say ROT for rotation is equal to C4D.utils dot, and it will be matrix rot x, matrix rotation, not tot, rot. Matrix rotation x is what we're going to be using here. And then we can say brackets once again, C4D.utils dot rad for radians and range mapper between the brackets. So we're taking 0 to 360 degrees and we're turning it into radians. That's what we're doing here. So that's that little bit of it set up. We can then say mar, and it's square brackets blue, open brackets I, double close, times equals, and it's ROT. And that will make our blue clones rotate around their x-axes. And then as we did before, it's simply a case of copying this else, pasting it in here, and putting a B on the end of start time. So start time underscore B dot clear. And that's our blues taken care of. That was quite simple to do. So now we can think about what we're going to be doing with our yellow clones. Working with these is actually going to be quite simple. We're going to be using the flip-flop to make them flash on and off. So we can say if flip underscore flop bracket 0 is equal to 1. And then we can use the flag array to switch them off and on accordingly. So we can say far brackets yellow brackets I double close. And then it's a bitwise function that you will have seen me use before. It's and equals, and then this little squiggly line, which means not. And then we can say c4d.mogen flag underscore clone underscore on. And that will actually switch the clones off. Even though it says Mogen clone on, it switches them off because we've got the bitwise function in front of it that actually makes that happen. So if the flip-flop is equal to 1, we're going to switch the clones off. If it's equal to 0, they're going to be switched on, and we don't even have to say that. It's really that simple. So that's as much as we need to do to control our yellow clones. And then finally, we want to work with the surround here. And what we're going to do, we're going to change the color of the surrounding clones one by one, moving up, along, and then down and back across. We're going to make it step through these, and they're going to be changed to a cyan color one at a time. So in order to do that, we simply need to say car for color array, open square brackets, surround, open square brackets, counter, and open square brackets again 0, and then treble close is equal to c4d dot vector brackets 0, 1, 1, and that will give the clones a cyan color. And that's as much as we need to do there. Just that one line of code is all we need. And of course, the values that are coming out of our counter. This up here is working with this down here. Okay, so all things being fair, that's as much code as we need to put in the animate function. So all we really need to do then is come down to here and say animate open close. And if I've done everything correctly, we should get the result that we want. Let's give this a go. Well, straight away, we've got a clone changing to cyan when we go back to 0. So that's fine. It's working. So let's hit play and see what happens. And look at that. Everything is working exactly as I said it would. It's working perfectly. So that's really great. It's good to see. Now, it's worth mentioning these two pieces of code are not in the main loop, and that's essential. Make sure you don't put these in the main loop. If you do anything similar to this, where you've got this here and you've got you're sequencing through your clones and checking everything that's going on within this main loop, make sure you don't put anything else that's doing anything to do with counters or flip-flops, or indeed anything else. If you've got random number generators as well, don't put them in the main loop. Always put them above it, okay? Because you'll get a structural error there, and you'll find it just won't work. Okay, so that's important to remember. But anyway, that just about brings this tutorial to a close, because I've shown you everything I wanted to show you, and it all works exactly as I said it would. So I hope you've learned something of value that you can use within your own projects. And if you have, then please give the video a like. And if you haven't already subscribed to the channel, then please do so. And of course, leave a comment and ring the bell. And wherever you happen to be on social media, then please share this video, because all of this good stuff helps to keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one. So I'll see you very, very soon on the next tutorial.